Hey everyone, welcome. Let's jump right into a super important topic from your real numbers chapter. We're going to totally master Euclid's division algorithm, and the best way to do that by solving 6 different problems step by step. Ready? Let's get started. So, have you ever tried to find the highest common factor, the HCF, for some really big numbers? It can be a real pain with prime factorization, right? Well, guess what? There's a much cooler, way more powerful method. It's called Euclid's algorithm, and it's basically a foolproof system that nails the right answer every single time. Seriously, it's a game changer.
Okay, so the secret sauce behind this whole thing is something called Euclid's division lemma. Now, it sounds complicated, but it's not. All it says is that for any two positive numbers, a and b, you can write it out like this. A equals b times q plus r. A is your dividend, b is the divisor, q is the quotient, and r, well, r is the star of the show, the remainder. And here's the golden rule, the one thing you have to remember. That remainder r must always be smaller than the divisor b. That one little rule is what makes the whole algorithm work.
So how does this little formula help us find the HCF? It's all about a simple, repeatable loop. It's like a little dance. Step 1, apply the lemma. Now, if your remainder is 0, bam, you're done. The HCF is just the divisor from that step. Easy, right? But what if the remainder isn't 0? No problem. We just do a clever little swap. The old divisor becomes the new dividend, and the remainder becomes the new divisor. Then you just repeat the process. You keep doing this until you corner that remainder and force it to become 0. It's guaranteed to happen. All right, enough talk. Let's actually see this thing in action. First up, we're going to find the HCF of 135 and 225. Okay, so we divide 225 by 135. Our first remainder is 90. Is that 0? Nope, so we loop. Now 135 is our new dividend, and 90 is our new divisor. We do the division, and what do we get? A new remainder of 45. Still not 0, so we go again. This time, 90 is the dividend, 45 is the divisor, and what do you know? It divides perfectly. We finally hit a remainder of 0, and that means our HCF is the last divisor we used, which is 45. See how that works? Okay, that was pretty quick, just 3 steps. But what happens when the numbers are a bit trickier? Let's really put this algorithm to the test and find the HCF of 196 and 382. This one might take a little longer.
Whoa, look at that. It's so cool to see how the remainders just cascade down one after another. It took a bunch of steps, didn't it? But that's the beauty of it. It doesn't matter how long it takes. The process is exactly the same, every single time. It just keeps chipping away at the problem, systematically, relentlessly, until it forces that remainder to 0. And in this case, it reveals that the HCF is 2. The method is just solid. It never fails. All right, let's keep the momentum going. Example number 3. Let's find the HCF of 867 and 255. Okay, let's trace this one. Our first remainder is 102. Not 0, so we loop. The next remainder is 51. Still not 0, but on the final step, 51 goes into 102 perfectly, leaving us with that magic remainder of 0. Remember the rule? The divisor that gives you that 0 remainder is your HCF. So for this one, it's 51. Simple as that. We're halfway there. Problem number 4. Let's find the HCF for 72 and 120. You know the drill by now. We follow the same exact process. First remainder is 48. Next step, our remainder is 24. And guess what? 24 goes into 48 perfectly. We hit our target, a remainder of 0. So our HCF has to be 24. We're in the home stretch now, just a couple more to go. For number 5, let's tackle the HCF of 84 and 30. Let's follow the path. We get a remainder of 24, then 6. And on that final step, 6 divides 24 perfectly. Ding, ding, ding. Remainder of 0. We know our HCF is 6. See how this is becoming almost second nature? All right, this is it, our last practice question. By now, I bet you can see the pattern from a mile away. Let's lock it in by finding the HCF of 144 and 60. Okay, let's walk through it one last time, nice and smooth. 144 divided by 60 leaves a remainder of 24. 60 divided by 24 leaves a remainder of 12. And finally, 24 divided by 12, it's a perfect match. Remainder is 0. The HCF is 12. And there you have it. We've just proven with 6 completely different pairs of numbers that this method is an absolute rock star. It works flawlessly every single time.
Okay, so we just blew through 6 different problems, but let's pause for a second and think big picture. Did you notice the one thing that happened every single time? What was the one guaranteed result we got in every single one of those solutions? This right here is the big aha moment. Just look at this. It doesn't matter if it took 3 steps or 6 steps. Every single pair of numbers we tried cascaded down until that remainder hit 0. The algorithm is, well, it's absolute. It's a guaranteed process that just keeps squeezing the numbers down until it reveals the one common truth they share, their highest common factor. That's what's so beautiful and elegant about this method. You know, getting the why behind a powerful tool like this one, that's the key to really mastering math. And that focus on the fundamentals, on building a rock-solid foundation, is exactly what we're all about at KSV Academy Olway. With our experienced teachers and lots of personal attention, we help you build those strong concepts. It's not just about passing exams, it's about really truly understanding the material. So if you feel like you're ready to take your learning to that next level, you should definitely check us out at KSV Academy.